All right, so we're going to be looking at measuring volume in the metric system. So remember, volume, we go from distance A, or point A to point B. That's our distance, or it's linear. Then we take that distance and cover it over a whole distance. And so we get a square distance, which we call area. Now we take that covering or surface and we expand it over a distance. And so now we get this whole thing that looks like a cube whenever it's perfect, and that's our volume. So within the metric system, we still have for distance, we have meters. So because this becomes a cube, and we call that cubic units, this would be cubic meters. Or if we use our other prefixes, we have cubic millimeters, cubic centimeters, cubic decimeters, cubic meters, cubic decameters, cubic hectometers, cubic kilometers. You can also say each of those just cubed. So that means we have each of these raised to the third power. That also means our conversion factors are each going to be raised to the third power. Okay? All right. So I could write out all of those, but to show you a different way, instead of writing a bunch of ones with zeros, I'm going to keep it a little simpler. So for this, we would have 1, 2, 3 zeros, and we would do that 3 times. Well, 3 times 3 is 9, right? So this would be the same as 10 to the 9th power, or 1 with 9 zeros, cubic meters. This 100 would just be 10 to the 2nd power, right? Well, if we take that 3 times, we have 10 to the 6th power. 2 times 3 is 6 cubic meters. If we then go here and we have 10 to the 3rd, well, that's just 10 to the 3rd cubic meters. 1 to the 3rd stays the same, it's just 1. Here we have a 10th though. So, that's 3 there. Yeah, there we go. All right, so here we have a 10th raised to the 3rd power. So this would be 10 to the negative 3 cubic meters. Why did I get negative? Because it would be 1/10. And remember, going back to our negative exponents, so we have 1/10. That's the same as 10 to the negative 1. Because when you have a negative exponent, that means take the reciprocal of it and then make the exponent positive. So the reciprocal of 10 over 1 would be 1 over 10. Just a refresher. All right, so what about this? Well, this is 100th raised to the 3rd power. So this would be 10 to the negative 6 cubic meters. And then lastly, you probably guessed this would be 10 to the negative 9 cubic meters, because these should also reflect across each other. All right, we could even, for the 1, we could put 10 to the 0 power, because anything to the 0 power is 1, unless we're doing 0 to the 0 power, which you can't do. So what does this all mean, and why did I even show that to you? Well, remember when we did engineering notation? Engineering notation had to very specifically have the power on the 10 as a multiple of 3. Notice how all of these have that. So whenever you're doing conversions with cubic metric system, you will have these 10s to these negative powers that are negative and positive powers that are multiples of 3. So you can very easily do engineering notation when you're doing these conversions. That's just something to keep in mind. Not something that you'll necessarily have to do, but it's something to keep in mind. So anyway, let's look at a conversion. That's what we're here for, right? To practice this. So I'm going to erase these again. Just remember, it goes negative 9, negative 6, negative 3, 0, 3, 6, 9. Or you can go back and calculate it. Let's look at a problem. So let's say I had 2,700 cubic millimeters. And I want to see, hey, How many cubic centimeters is that? So 2,700 cubic millimeters is how many cubic centimeters? Well, let's find out. So I have 2,700 cubic millimeters. And what I do know is that going from one of these to the other is just the power of 10, right? Yeah, because each of these is just like a place value. So if I have millimeters, it would take 10 of them in order to make 1 centimeter. Okay? That's just the power of 10. Like this is 1,000. This is 1,000. This is 100. So take 10 thousandths to make 100. All right. If you can't see that, I'll write it out. 100th would be equal to 10 thousandths. Some of you might be able to see that a lot easier if you can see the zero going away. Okay. All right. But we're looking at cubic units. These aren't cubed. So what do I need to do? Cube it. And I cube my conversion factor as well. Okay, so we have 2,700 being multiplied by 1 to the third, which would just be 1, so just be 2,700. Then divided by 10 to the third. So I have 2,700. My cubic meters, millimeters would cancel. So I have cubic centimeters. So I have 2,700 divided by 10 to the third power. Well, if you want to get rid of some zeros, you can. So this would just be 27 over 10, or 2.7 cubic centimeters. Okay, awesome. Well, whenever measuring volume, just remember, no matter what kind of units you have, take the base unit, and you cube each part of the conversion factors, and you convert it as normal. Also remember, when we're dealing with a metric system and our prefixes, these are all based off powers of 10, just like the place values. And honestly, you'll be fine. So that's measuring volume with the metric system. I'll see you soon.